Okay, problems 3 and 4, we are trying to solve the system by either substitution or elimination. So as we look at number 3 here, the thing I'm looking for first are the x and y's and equal signs matched up? Well, if they were, I would do elimination. This is not going to be an elimination problem because I have what x is equal to. Right there it says x equals that thing. So what I'm going to do is in the other problem, so in this equation right here, I'm going to plug in for x that 2y minus 1 right there. So I'm going to take all of that thing and put it in where the x was. So my new problem is going to be this, 5. Instead of x, I'm going to plug in that part right there, minus 7y equals 4. So where that x was, I am putting that 2y minus 1 inside. That whole part right here is going in right next to that 5. Once I've done that, I'm just solving. So I'm distributing. Just distributed, 5 times 2, 5 times negative 1. Now I can combine like terms. So here I've got this 10y and that negative 7y. So 10 minus 7 is 3y. I'm going to add this 5 to the other side. So that's 9. And then I'm going to solve. So I'm going to divide by 3, y equals 3. Once I get an answer, okay, the whole goal is to get an ordered pair. I know what one of my numbers is. One of the numbers is 3. I'm trying to find the other one. Well, to find the other number, I am taking this 3 right here, and I am plugging it into one of those equations. I like that one, so I'm going to plug it in there. So I've kind of run out of space here, but I'll put it right here. X equals 2 times, instead of y, I'm plugging in what y is now, which is 3, minus 1. So x equals 2 times 3 is 6, minus 1, x is 5. So my y value, my x value is 5. There we go. Substitution, again, we did substitution because x is by itself at the beginning. We substituted in for x. Problem 4, we look at number 4. We look, the x's are lined up. Okay, I got the 2x on top of the 4x. I got the 5y on top of the 10y. My equal signs are matched up. This is a good problem for elimination. So we want to do elimination on this problem. So as we look, we're trying to decide what can I do to get rid of one of the x's or one of the y's. Well, as I look at this one, I've got a positive 2x here and a positive 4x there. Since the 4x is bigger, I'm going to think in my brain, what can I multiply this top row by to get the opposite of 4x? So this equation right here is 4x plus 10y equals negative 12. The opposite of 4x to me, and to everybody, is negative 4x. So what would I need to multiply this whole thing by to give me that negative 4x there? And hopefully you're thinking negative 2, because that's what I need to do. If I took negative 2 and multiplied that out, so negative 2 by each thing, and let's distribute that out, and we're going to write it down here. So negative 2 times 2x is negative 4x. That's what we wanted. We wanted it to be the opposite of positive 4x. And then negative 2 times 5 is negative 10y. And then negative 2 times negative 6 would be positive 12. We're putting those things together. Hey, look, I made the x's be opposite. When I combine those together, they are going to cancel out to get me 0. Hey, look, what happened? I got 10y and a negative 10y. When I put those together, it gets me 0. I do it again. I get negative 12 plus 12. I add them together. It gets me 0. No letters are left. X's and y's both canceled out. And we're going to look at the end problem. Right now it says 0 equals 0. Does 0 equal 0? Does that make sense? Hopefully, yeah, that's a true statement. Like 3 equals 3. Yeah, 3 equals 3. Or 0 equals 0. When that happens, okay, that means we have infinitely many solutions. So just like we got on number 4, or on number 1, infinitely many solutions. Just like we got up on this first problem where the two lines were on top of each other, that was infinitely many solutions. Same thing here. When I do an elimination or a substitution and I get a true statement at the end like 0 equals 0, that also indicates to me that there are many solutions. Basically, that they're the exact same equation.